Okay, welcome back. We're here to talk about section 1.8, which is problems involving two unknowns. Right? So most of our problems have simply had one thing that we don't know, but you may come to a situation where there are two things you don't know. And in this section, those two things have to relate to each other. And if they do relate to each other, then we can solve the problem using simply one unknown. So let's take a look at an example and how to work through it. Let's say Janet has 18 coins in her purse. This is the first example, just right below if you want to read along and follow. But, she has 18 coins. And they're all either nickels or quarters. And if we know that she has a certain amount, $2.10 in this case, then the question is, how many of each type nickels and how many quarters does she have? So that's our problem, that's what we want to figure out, right? Understand the question. Well, Janet has some coins in her purse. What we really want to do at the end of the day is figure out how many nickels she has and how many quarters she has, right? So what we want to do is identify our unknowns, and the unknowns are the number of nickels and the number of quarters. Those are our unknowns, and they're what we're looking for. That's what we want to figure out at the end of the day, right? So, how many nickels do I have? I don't know. I have no idea, so I'm going to call that X. Right? And then I have this other quantity, the number of quarters, I also don't know. So I could call it Y, but I don't want to. What I want to do is know that there's a relationship between the two of these that's going to help me get rid of a second variable, right? So if you think about it this way, if you have $1 and I take 45 cents, how much do you have left? And I haven't told you anything about how much you have left except that how much I've taken. And since you know what you started with, you just take what you started with minus what I've taken, and that is what you have left. And that thought can be applied to the number of quarters. You have $2.10, right? Or actually, sorry, we're going to look at this. You have 18 coins, right? And we're saying that X of the 18 are nickels, and so the difference has to be how many quarters you have. So that's what I'll put here. Instead of a different variable, I'm going to say that if X of my 18 coins are nickels, then 18 minus X, the difference between what I started with and what has been designated as nickels, that has to be quarters, right? And so I have two expressions for my unknowns, but I only have one variable, and that's what this section, excuse me, what this section is about. We're going to revisit questions like this where we can just say, well, call this Y and what happens, and then you need two equations, right? And we can create those, but this is sidestepping that for now and just sticking with one equation with one variable, right? So now that I know these, I can create an equation, right? And that equation has to do with the money, how much these things are worth. I know that nickels are 5 cents, and I have X nickels, so the total value that I have in nickels is 0.05, the value of a nickel multiplied by the number of nickels that I have. I know the value of my quarters is 25 cents each, multiplied by the number of quarters I have, which is 18 minus X. So I have two more expressions here. 0.05x is the value of all of my nickels. 0.25 times 18 minus x is the value of all of my quarters. And that's everything. That's the whole bucket. And so if I add these two things together, it has to be $2.10. And there's my equation. Now I'm going to have to work this equation, so I'm going to get rid of all of this work here. If you need to pause the video, do it now, because here it goes. So I'm going to rewrite this up here as 0.05x plus, and I will distribute here. So that's 4.5 minus 0.25x. And then equals 2.1. Am I going too high? That might be a wee bit too high. Looks like I can still see it, but I'll keep it low, a little bit lower. And so if I combine like terms here, I can combine 0.05x and negative 0.25x. Now recall here that 0.25 in magnitude is larger than 0.05, so my negative number is greater in magnitude than my positive number, so I should end up with a negative number here. So that is negative 0.2x plus 4.5 equals 2.1. And at this point, other than the fact that we have decimals, and maybe you don't like decimals, if you don't, multiply everything by 100 and get rid of them. But it's reduced down to section 1.3 and section 1.2 type question, right? And so I'll use my addition principle, minus 4.5 from both sides. That leaves me with negative 0.2x equals negative 2.4. Right? And if I want to isolate the x, I divide each side by negative 0.2. That eliminates that and leaves me with just an x. On the right hand, divided by negative 0.2, gets rid of that, and it gives me 12. And that's it. So I found one of the things I wanted to find. Recall that we said x is the number of nickels, and 18 minus x is the number of quarters, and we were asked to find both, right? So x, there's 12 nickels. 18 minus 12 is 6, and therefore there are 6 quarters. Right? And you can do the math here. 12 nickels at 5 cents a pop, that's 60 cents. 6 quarters, right? 4 quarters and $1, that's $1.50. That all adds up to 210. So I've checked it, I get 210 out of what I have 18 coins, that's my solution. Okay, let's look at another one like that. Let's say, in fact, let's just do the next example in the book here. Java Joe's Coffee Shop sells 2 kinds of coffee. We have Mountain Aroma. Mountain Aroma sells for $8 per pound. We also have Blue Ivy. which sells for $6.50 a pound. Joe, the coffee shop owner, wants to mix to sell for $7 a pound, and he wants 30 pounds of it. So I'm going to write, he wants 30 pounds of a mix to sell for $7 per pound. Okay. And then the question is, how much of each type should we mix to make it a $7 per pound mixture, right? So I have a couple of unknowns here. Those unknowns are the amount of Mountain Aroma. I'm just going to write MA, Mountain Aroma coffee. So we're going to call that probably X. Right? I also don't know the amount of Blue Ivy, which we're going to abbreviate BI. Right? But if I know that he wants 30 pounds total, I've already designated X to be the number of pounds of Mountain Aroma, very similar to the last problem. Then Blue Ivy is then 30 minus X. That's how many pounds. Right? And again, very similarly to the last question, I'm going to create an equation using the money. Right? So this one's a little bit different because in the last problem we had the total amount given to us. She had $2.10. Here we're given a rate. We're selling this for $7 a pound, right? So if I look at what's happening here, the Mountain Aroma sells for $8 per pound, and so the value of the Mountain Aroma in my mixture is $8 multiplied by the number of pounds that I've put in. And similarly, the Blue Ivy is $6.50, so 6.5, multiplied by 30 minus X. Again, that is the cost per pound multiplied by the number of pounds. So this is pure dollars. $8 a pound multiplied by a number of pounds, pure dollars. $6.50 per pound multiplied by a number of pounds, pure dollars. So what I want on the other side of this equation is just pure dollars, right? But $7 per pound is not pure dollars, it's dollars divided by pounds. And so I need to do the same thing that I've done here and multiply the $7 per pound by the amount, which I know, which is $30, 30 pounds, excuse me. So that is $7 per pound multiplied by 30 pounds, pure dollars, right? My units have to match up. We're not going to take too much time to talk about units in this class. They will come around in later classes, in physics classes and chemistry. But the units do match up here. Dollars plus dollars equals dollars, right? So let's simplify a little bit. I can take this 6.5 and distribute it through there. 6.5 times 30 is 195. 180 plus 15, so 195, yes. So I've got 8x plus 195 minus 6.5x equals 7 times 30, 210, right? And that's my equation. And once again, the hard part is creating this equation. Once I simplify it, we're all the way back to 1.3 again, right? So let's take this. If you need to pause, write this down, do it now, because here it goes. When I write it up here, what I'm going to do is combine my x terms. I have 8x minus 6.5x, that's just 1.5x left over. plus 195 equals 210. Right. Gonna get rid of this one too. Here it goes. And if I subtract 195 from both sides, that gives me 15. So I have 1.5x equals 15. Not bad numbers, because when I divide this by 1.5, I get x equals 10. Which is to say that I have 10, and if you recall, I hope you have them in your notes, I had to erase them, but 10 was, x was the number of pounds of mountain aroma, is that what it was called? Yeah. And therefore, the other one was 30 minus x, which is 30 minus 10, so that's 20. So I have 10 pounds of the mountain aroma, and I have 20 pounds of blue ivy, or whatever it's called. Good. All right, let's take a look at a mixture problem. That's kind of what this was here, but we're going to talk about a like a chemical mixture. Those ones seem to be a little bit less favored. Most people don't like those. But I'm going to do that in a second video so that my videos have a 25 minute, something like that time limit. So I'm going to stop this one, start a new one next, and that'll be your chemical mixtures.